and welcome to the Down the Spirituality and Science Rabbit Hole podcast number 12, Quantum Weirdness, a Harbinger of Spiritual Reality. Now, the Buddhists have a philosophy that the great spiritual teachers are not the object of enlightenment. The teachers only point you in the correct direction to the final goal. The rest is up to you. There is a common Buddhist maxim: a great teacher is like a finger pointing at the moon. However, the teacher is not the moon. Also, it could be rephrased as, Moses was not the Torah. He simply pointed to the Torah. Or, Jesus was not the kingdom of God. He simply pointed to the kingdom of God. It is important not to lose sight of this idea, as we will return to it at the end of the podcast. Likewise, physics and quantum field theory do not prove that there is a spiritual reality. However, these disciplines may point to or hint at a spiritual reality. In the end, a science experiment can never prove anything. It can only nullify or support a particular hypothesis. The scientist, and sometimes the philosopher, has the job of putting all the pieces not proven false together into a coherent whole. But remember, any scientific theory is only one experiment away from being questioned and disproved. Quantum mechanics, the fundamental theory that governs the behavior of particles at the atomic level, has revolutionized our understanding of the universe. Its development marked a paradigm shift in scientific thinking, challenging the classical notions of cause and effect, and opening up a realm of possibilities that were once unimaginable. As quantum mechanics continued to evolve, it became increasingly apparent that the theory had implications beyond the realm of physics. Its connection to the spiritual is significant as physicists delve deeper into the mysterious nature of phenomena such as quantum entanglement and superposition. Quantum physics offers us a new lens through which to view the mysteries of consciousness, bridging the gap between science and spirituality. By embracing the enigmatic nature of quantum physics and the profound potential it holds, we may unlock the secrets of our spiritual existence and awaken to a reality that is far more expansive than we ever thought possible. At its core, quantum physics reveals that the universe is not a fixed and predictable entity, but rather a realm pregnant with infinite possibilities. Now, this podcast is a continuation and to some degree a clarification of podcast number 9, The Metaphysics of Spirituality. Reductionists are those who take one theory or phenomena to be reducible to some other theory or phenomena. In philosophy, it is a view that asserts that entities of a given kind are identical to or are collections or combinations of entities of another, often similar or more basic kind, or that expressions denoting such entities are definable in terms of expressions denoting other entities. That's quite a mouthful. But, for example, a reductionist regarding mathematics might take any given mathematical theory to be reducible to logic or set theory. Or a reductionist about biological entities, like cells, may take such entities to be reducible to collections of physiological chemical entities like atoms and molecules. The type of reductionism that is currently of most interest in metaphysics and philosophy of mind involves the claim that all sciences are reducible to physics. This is usually taken to entail that all phenomena, including mental phenomena like consciousness, are identical to physical phenomena. One concern with this theory of scientific reductionism overall is that the process in similar components may simplify the situation too much, and thus the whole could get distorted. For example, information in the physical sciences would not allow one to predict life or psychology. A brief note here before we get started on the main topic regarding size and our place in the universe. In the Middle Ages, people found out that humans did not have a privileged place in the cosmos. We are not the center of the universe. The sun and the solar system does not revolve around the earth, nor does the universe revolve around the earth. However, humans, it turns out, do have a privileged position regarding size. On the left-hand picture here, you see the universe is not infinite. It has a lower bound and it has an upper bound. We know the lower bound from quantum mechanics. We know the upper bound from cosmology. And if you look, you see that life appears in the middle. The picture on the right shows a little bit more detail, and you'll see that the size of a human being is exactly in the middle between the realm of the very small quantum and the realm of the very large cosmos. This really does give us a privileged position in that we are in a position where we have equal access to both the very small and the very large, which is somewhat illuminating. So here is what we will consider in this particular podcast. The world of quantum physics is a realm of endless possibilities where the laws of classical physics break down and reality becomes a wondrous tapestry of possibilities and probabilities. It is a field that has fascinated scientists, philosophers, and theologians alike, challenging our understanding of the fundamental nature of the universe. Quantum physics teaches us that reality is not as fixed and deterministic as we once believed. Instead, it presents a dynamic universe where observation and consciousness play a central role in the shaping of our experiences. By understanding the principles of quantum mechanics, we can begin to comprehend how the mind may provide access to alternative realities, allowing us to tap into a vast reservoir of information and possibilities. We will consider 6 varieties of quantum weirdness. Number 1 are quantum jumps. Number 2 is the superposition principle. Number 3 is the wave-particle duality demonstrated by interference. Number 4 is the primacy of fields over matter. Number 5 is quantum entanglement. And number 6 is the zero-point field. This picture is a metaphor for the atom and not an actual depiction of what is happening in real space. In other words, it's not what an atom truly looks like, but it's useful to get the point across here. Note that in a quantum jump, the electron hops from one allowed orbit to another without ever residing in the space in between orbits. This is the picture on the left. In normal Newtonian motion through space, which is the atom on the right, the moving particle passes through all the space in between the starting and ending points. So in a quantum jump, the electron literally disappears from the universe, only to reappear in the universe in a new energy level. Also, the term subatomic particle is a real misnomer. Things like electrons are more like a wave in a box or a standing wave. It is actually the standing wave which makes the quantum jump, not a particle like we think about like a marble. The following video that you're about to see will show you what these standing waves look like that we call particles. Now, note that the shape of the wave changes with energy. You may also want to view the video several times to get everything that's in the video. So, electron superposition is a hint that comes to us through the world of quantum mechanics. Now, if you look on the left-hand side of the screen here, you'll see what everybody thinks is a picture of what an atom looks like. This picture of the atom shows the nucleus with protons and neutrons and electrons circling the nucleus like planets circle the sun. This representation of the atom has been known to be factually incorrect for over 100 years. It's impossible for electrons to circle the nucleus because any moving electrical charge gives off radio waves. Radio waves are a form of energy, so the electron would eventually spiral down into the nucleus very, very rapidly. Also, it would mean that all matter would give off radio waves, which it certainly doesn't. So why in the world is this still taught? The reason why it's still taught is that the reality is just too weird. On the right, you see what the electron really looks like. The electrons are in a superposition cloud. In other words, all the places that the electron could be are superimposed on top of each other, and the electron only manifests itself in a particular position when someone measures it. That certainly doesn't agree with the way things act in consensus reality and has been perplexing physicists for almost over 100 years. So, at the heart of quantum physics is the concept of superposition, where particles can exist in multiple states simultaneously until observed or measured. This phenomenon defies our classical understanding of how the world works, raising profound questions about the nature of reality itself. This principle suggests that a particle can exist in multiple states simultaneously until it is observed or measured. It is remarkably similar to the realm of dreams, where we can experience multiple realities simultaneously and where different aspects of our consciousness unfold in parallel. In the realm of dreams, our minds transcend the boundaries of our physical reality, exploring parallel dimensions and ultimate versions of ourselves. It is within this ethereal landscape that the interplay between quantum physics and parallel realities becomes evident. Quantum physics tells us that particles can exist in multiple states simultaneously. Similar in our dreams, we can experience multiple realities coexisting, and the impossible becomes possible. The observer effect implies that particles exist in a state of superposition. However, when observed, these particles collapse into a single state. This raises profound questions about the nature of reality and the role of consciousness in shaping it. The next video shows how electrons are standing waves at different energy levels around the nucleus. So now we come to science's most favorite cat. In Schrodinger's original formulation, a cat, a flask of poison, and a radioactive source are placed in a sealed box. If an internal radiation monitor, a Geiger counter, detects radioactivity, which would be a single atom decaying, the flask is shattered, releasing the poison which kills the cat. The Copenhagen interpretation implies that after a while, the cat is simultaneously alive and dead. Yet when one looks in the box, one sees the cat either alive or dead, not both alive and dead. This poses the question of when exactly quantum superposition ends and reality resolves into one possibility or the other. In quantum mechanics, Schrödinger's cat is a thought experiment, sometimes described as a paradox of quantum superposition. In the thought experiment, a hypothetical cat may be considered simultaneously both alive and dead while it is unobserved and in a closed box, as a result of its fate being linked to a random subatomic event such as radioactive decay that may or may not occur. This thought experiment was devised by physicist Erwin Schrödinger in 1935 in a discussion with Albert Einstein to illustrate what Schrödinger saw as the problems of the Copenhagen interpretation of quantum mechanics. So, a brief aside, the Copenhagen interpretation was formulated by Niels Bohr, who happened to live in Denmark, and it basically states that just do the calculations because the calculations work very well, but don't think about what the calculations actually mean to the real world. In other words, calculate, but don't think about what it means. Schrödinger's famous thought experiment poses the question, when does a quantum system stop existing as a superposition of states and become one or the other? Our intuition says that no observer can be in more than one state simultaneously. Yet the cat, it seems from the thought experiment, can be in such a condition. Is the cat required to be an observer of itself? Or does its existence in a single well-defined classical state require another external observer? In physics, quantum tunneling, barrier penetration, or simply tunneling, is a quantum mechanical phenomenon in which an object such as an electron or atom passes through a potential energy barrier that, according to classical mechanics, the object does not have sufficient energy to enter or surmount. Tunneling is a quantum mechanical effect. A tunneling current occurs when electrons move through a barrier that they classically shouldn't be able to move through. In classical terms, if you don't have enough energy to move over a barrier, you won't. Quantum tunneling is the basis of almost all semiconductor electronic components. It is literally a significant feature of modern life. All electronics are dependent on this bizarre effect. The pictures here demonstrate the point. In classical mechanics, if you're confronted with a barrier, you have to climb over it. But in quantum mechanics, you simply, at some point, can go through the barrier. The pictures here are a bit simplistic and misleading in that the electron does not move progressively through the space, but rather makes a quantum jump across the barrier. In other words, the electron disappears from the universe in front of the barrier, only to jump and reappear magically on the other side. The next video demonstrates the electron tunneling effect. Again, the electrons are shown as waves and not particles. So we now move to what many people consider the most important experiment that's ever been done in physics. Young's interference experiment, also called Young's double-slit interferometer, was performed at the beginning of the 19th century by Thomas Young. This experiment played a major role in the general acceptance of the wave theory of light. In Young's own terms, this was the most important of his many achievements. The interference phenomenon, were known long before the quantum mechanical era, notably in the behavior of light waves. Suppose you shine a light at a screen with two slits in it and project the result onto a further screen. Initially, suppose that the left-hand slit is open, but the right-hand slit is blocked. Then the screen is illuminated beyond the open slit as shown in the center diagram. Similarly, if the right-hand slit is open and the left-hand slit is blocked, the screen is illuminated behind the right-hand slit as shown in the left diagram. But if both slits are open, the illumination on the screen is not the sum of those in the left and the center diagrams, but rather it is a pattern of light and dark bands shown in the right-hand diagram. This behavior can be readily understood in terms of the mechanics of light waves, as shown here. The waves spread out from the source until they encounter the first screen, where most of the wave is blocked. When one slit is open, as in the left diagram, some of the wave passes through the open slit and spreads out until it hits the second screen. This explains the illumination of the screen behind the open slit. When both slits are open, as in the right diagram, some of the wave passes through each slit and the two wave components spread out and overlap before they hit the second screen. In other words, they interfere. In this overlap region, interference occurs. That is, the waves from the two slits add up in some directions and cancel out in others. The solid lines represent the wave peaks, and in some directions, marked by the dashed lines, you can see that the lines emanating from each slit cross, meaning that the peaks coincide. In these directions, the waves from the two slits reinforce each other, resulting in a bright band on the screen. Between these directions, the peak from the one slit coincides with the troughs from another. Here the waves of the two slits cancel each other out, resulting in the dark band on the screen. A more surprising phenomenon is the production of an interference pattern like this using a stream of electrons instead of a beam of light. Suppose that the light source is replaced by an electron gun, like that at the back of an old-fashioned television tube, and the display screen is replaced by a fluorescent screen like that on the front of such television. Classically, electrons are viewed as particles, essentially as like little billiard balls traveling through space. Whereas a wave can pass through both slits and then interfere, a particle, by its point-like nature, has to pass through one slit or the other, so any explanation of interference is ruled out. That is, if the electron passes through the left-hand slit, then it can make no difference to the path of the electron whether the right-hand slit is open or not. So the pattern where both slits are open has to be simply the sum of the single slit patterns. This is what Louis de Broglie in 1924 proposed, that every so-called particle can be treated as a wave with a wavelength. These wavelengths are very small. For an electron at typical lab velocities, the de Broglie wavelength is around a nanometer, which is a billionth of a meter, compared to several hundred nanometers for the wavelengths of visible light. So far, though, the explanation of electron interference doesn't require any fundamental metaphysical reorientation. Electrons are simply reclassified as waves rather than particles, but the basic classical meaning of waves and particles remains intact. In fact, though, the situation is far more mysterious than it at first appears. Suppose we reduce the firing rate of the electron gun so that the electrons pass through the slits one at a time. Each electron produces a flash at a single precise point on the fluorescent screen. But if we look at the distribution of the flashes over time, we see that it forms an interference pattern. that the interference pattern is present even though the electrons pass through the apparatus singly. Each electron interferes with itself, not with other electrons. But more problematically, the explanation for what we see seems to require that we treat the electron both as a wave and a particle. The explanation of the interference pattern apparently requires that each electron behaves as a wave passing through the slits, but the explanation of the discrete flashes apparently requires that each electron behaves as a particle, and a particle passes through one slit or the other. The classical explanation of this phenomena is flat out contradictory, describing the same entity simultaneously as a discrete particle and as a spread out wave. There was at one time a pilot wave theory proposing that generated significant interest, that it might successfully explain this. It contended that a wave guided the particle through the apparatus to form the interference pattern. It still has adherents today, but there are better, less problematic explanations that we will see later. We cannot simply combine elements of our classical metaphysical picture to form an inconsistent hybrid. If we are to solve this mystery, it seems, we need to replace our classical metaphysics with something else entirely. The final video demonstrates the double slit experiment using 1. A real-world particle, 2. A wave or a field, 3. A quantum object particle like an electron, and 4. The presence of a slit observer trying to see which slit the particle goes through. The slit observer experiment, which was number 4, tends to refute the pilot wave theory. You will certainly need to watch this video more than once. Another important principle is that of entanglement. It has just been very recently confirmed, recently being 1980 when the first experiment was successfully done, but it has been duplicated thousands and thousands of times. And the conclusions of these experiments are astounding. According to this principle, particles that have interacted with each other become entangled, meaning that the state of one particle is dependent on the state of the other, regardless of the distance between them. The uncertainty principle introduced by Werner Heisenberg states that there are inherent limits to the precision with which certain pairs of physical properties of a particle, such as position and a momentum, can be known simultaneously. Now, the important thing stated here is entangled particles are entangled regardless of the distance between them. You could have one particle on one side of the universe and another particle on the other side of the universe, and somehow they would know what was happening to each other. This next hint is from what is probably the most important physics experiment that's ever been done. It was done in 1980 by a man by the name of Alain Aspect in France. Since 1980, this experiment has been duplicated multiple times in thousands of labs around the world. It's conceptually fairly simple. The apparatus that they use to do it is highly complex, but the idea here is you have two particles that are entangled. It means they were created together. And you're going to measure a property of them, and we'll call that property either red or blue. So until they're measured, just like the superposition of the electrons in an atom, these entangled particles are both red and blue. Now, when you measure, and these particles have been created and they're now separated. If you measure one particle and you find out that it's red, the other entangled particle instantly becomes blue. Same is true if you measure one particle and it turns out to be blue, the other particle instantaneously becomes red. Now, I know everybody's thinking, well, big whoop, that's nice, but what's it got to do with anything? Let's take these particles and let them separate. Let them separate well past where the speed of light can communicate between the two. And lo and behold, what the experiment said was that even that these particles were further than what the speed of light can account for, when you measured one, the other one instantaneously became the opposite. This basically means the universe is non-local. And that's an incredibly important thing to say. Let me try and phrase it a little bit in a more understandable fashion. I hit a baseball here on planet Earth, and it causes something to instantaneously happen in the Andromeda galaxy, separated by millions of light years. That means that the whole universe is interconnected, in doing something in one place can instantaneously affect something very far removed in another place. That's getting almost downright spiritual in terms of what it means. It means that everything in the universe is affected by everything else. Quantum entanglement refers to the mysterious and instantaneous correlation that exists between particles, even when they are separated by vast distances. It defies our classical understanding of cause and effect, as the entangled particles seem to communicate with each other faster than the speed of light. This phenomena has left scientists and philosophers scratching their heads, and it holds immense implication for our understanding of the nature of reality. Quantum field theory emerged from the work of generations of theoretical physicists spanning much of the 20th century. Its development began in the 1920s with the description of interactions between light and electrons, culminating in the first quantum field theory of quantum electrodynamics. And it's actually a much better explanation to the double-slit experiment than the pilot wave theory. Quantum field theory treats particles as excited states of their underlying quantum fields, which are more fundamental than the particles. Quantum field theory actually changes the way we view reality and our place in the universe. The take-home message of quantum field theory is particles are pieces of matter that occupy a discrete point in space. They are local. Think of marbles and dust motes. Matter particles are detectable by the human senses. On the other hand, a field is a fundamental property of space and is spread out through the entirety of the universe. A field has no accurately defined position. It is extended. It is what we call non-local. Fields are not detectable by human senses without instruments. However, they may be able to influence the human brain directly through consciousness. There are quantum fields associated with both energy and matter. Therefore, fields are primary and are the fundamental basis of the universe and reality. Therefore, all matter is an epiphenomenon of fields, which means that matter is derived and has its origins in fields. To rephrase, all particles are created by fields. It has been suggested by many scientists that there are fields associated with human consciousness, and these fields can interact with quantum fields. The interaction of these fields could be the basis for what people call the spiritual. Einstein just called it spooky action at a distance. We now come to zero-point energy, or the zero-point field. Zero-point energy is the lowest possible energy that a quantum mechanical system may have. Unlike in classical mechanics, quantum systems constantly fluctuate in their lowest energy state as described by the Heisenberg uncertainty principle. Therefore, even at a temperature of absolute zero, where all molecular motion stops, absolute zero is minus 460 degrees Fahrenheit. Apart from atoms and molecules, the empty space of the vacuum also has these properties of fluctuation. According to quantum field theory, the universe can be thought of not as isolated particles, but continuously fluctuating field. Matter fields, whose quanta are fermion, and force fields, whose quanta are bosons, all have zero-point energy. These fluctuating zero-point fields lead to a kind of reintroduction of what it was known in the good old days as the ether in physics. Since there are some ways that we can detect the zero-point energy. The idea that empty space can have an intrinsic energy associated with it, and that there is no such thing as a true vacuum, is seemingly very unintuitive. It is often argued that the entire universe is completely bathed in the zero-point radiation, and as such, it can add only some constant amount to the calculations. Physical measurements were therefore reveal only deviations from these values, which then average out to zero, hence the name of the field as the zero-point field. So, one final mind-exploding concept. I hear you thinking that if the average energy of the zero-point field is zero, then it can have no effect on the real world. And you couldn't be more wrong. Many physical effects attributed to the zero-point energy have been experimentally verified, such as the Casimir force. It is also the possible explanation for inertia. So, the Casimir experiment has two exquisitely polished plates. These plates are polished so well that molecules couldn't even exist between them if you push them together. The zero-point field is shown in green. And what happens if you take these highly polished plates and push them together so that they contact each other, what is happening is you exclude the zero-point energy from between the two plates, which is shown there by the double-sided blue arrow. That means that the pressure, there's no zero-point energy in between the plates, which means the zero-point energy is pressing against both plates on the outside, shown by the large blue single arrows. This force is so intense, you cannot pull these plates apart. The only way you can get them apart is to slide them past each other. They are literally glued in place better than super glue with the zero-point field. Now, let's consider inertia. Inertia is a property of space and matter by which matter continues in its existing state of rest or uniform motion in a straight line unless the state is changed by an external force. Anything that has mass takes energy to overcome inertia in order to move. Why? Because matter is pushing against the 0 point energy and must overcome that energy in order to move. The more mass, the more force is needed to overcome the 0 point field. How hard is it to move a marble, or a bowling ball, or a car? Again, the more mass, the harder it is to push against the 0 point field. As we have seen with the Casimir experiment, the 0 point energy is strong enough to cement two pieces of metal together. I will leave everyone with this final thought. There are many concepts and definitions of God. I will address some of these in a future podcast, but for now, I will leave this with you. We have considered 6 major consequences of quantum theory that are very counterintuitive to how we view reality. What people call the spiritual is also counterintuitive to our experience of the generally perceived real world. Might there be a connection here? So while quantum theory can never prove God, it might be the finger pointing to what many have called the mind of God, which may also be a field.